In this video, we'll be looking at the area and perimeter of regular polygons. So, some vocab that you need to know is that a regular polygon, first, is a polygon where all sides and all angles are congruent. We learned this back in the first semester. In each regular polygon, there's two pieces. There's something called an apothem, which is the perpendicular distance from the center of the polygon to a side, also cuts the side in half, and the radius. Oops, that up there. Okay, and the radius. And that is the distance from the center of the polygon to a vertex. So the apothem is the perpendicular distance from the center to the side, cutting it in half at a 90-degree angle. And the radius is the distance from the center of the polygon to a vertex. And it actually cuts the vertex into half. So we can look at these a little more in depth. If we take the radius of a regular polygon, it actually puts a circle around the regular polygon. We call the polygon now inscribed because it's inside of the circle. The apothem, however, is when the polygon is circumscribing, going around the circle. So that's a little interesting fact that the apothem and the radius work like that. They're two separate circles, kind of. So in an equilateral triangle, if you have your apothem and your radius, if you draw the radius, what do you think these angles are going to be right here? Well, if their equilateral triangle is normally 60, then each of these will be 30 and 30, which makes this a 60. So you can see here in an equilateral triangle, you get a special right triangle inside of it, with this piece also being congruent to this piece. In a square, if the radius cuts the 90 in half, you get 45 and 45, which makes this up here 45. So in a square, you get a special right triangle inside as well with the apothem and the radius. And finally, in a regular hexagon, that's all six sides and angles are the same. If you think about this whole angle, if you remember your formula, 180 times n minus 2 divided by n, because all the angles are the same. If you plug in 6, you get that an angle equals 120. So it makes this 60 and 60, and then up here, of course, would be 30. So another 30, 60, 90 triangle. This formula is good to know for this unit because sometimes you have to figure out how much goes in each angle. All right, so you can finally see here that this regular hexagon makes a 30, 60, 90 triangle here. And make sure that you do know that formula. All right, so here's kind of a review of what we just did. Special right triangles. The equilateral triangle has a 30, 60, 90. Squares 45, 45, 90. And regular hexagons 30, 60, 90. An easy way to remember that what goes where is a triangle has 3 sides, so 30 goes there. Square has 4 sides, so 45 there. And a hexagon has 6 sides, so 60 goes down there. All right, so let's try to see what this formula is going to be. So if you look at this regular pentagon, it has 5 sides, so the perimeter will be 5s. Now, you could find the area of this triangle pretty easily. S times A over 2, base times height over 2, right? And there's 5 of those, so 5SA over 2. Notice this right here is the perimeter. This is the apothem over 2. So that leads us to our formula, which is area equals apothem times perimeter divided by 2. And of course, the perimeter is just taking in the number of sides and multiplying by the length of one side because all the sides are the same in a regular polygon. So let's try some out. Find the area of a regular hexagon inscribed in a circle with a radius of 4 root 3. So 4 root 3 would go right here. Now, if this is a hexagon, it has 6 sides, so a 60-degree angle would go down here, and a 30-degree would go up there. So we have the 90, so the 30 side right here will be 2 root 3. And to go from the 30 side to the 60 side, we multiply by square root of 3. So root 3 times root 3 is just 3. So 2 times 3 is 6. So the apothem is 6. We just got to figure out what the perimeter is now. So if this is 2 root 3, this piece is 2 root 3. So a whole side is 4 root 3. There's 6 sides. So 6 times 4 root 3 is 24 root 3. So AP over 2 gives you, let's see, 6 times 24 is 144 root 3. over 2, which is 72 square root 3 centimeters squared. So you really do have to know your 30, 60, 90 rules here. All right, I want you to pause the video and try it with an equilateral triangle. All right, let's see how you did. So the radius is 6 root 3, and we want to find the area. So it's got 3 sides, so the 30 goes down here. Of course, that only works for the triangle, square, and hexagon. 60 goes up here. So we know our 90, so our 30 side will be 3 root 3. And to get to our 60, we have to multiply by root 3. So that gives you 3 times 3, which is 9, which makes this 9, and this whole side would then be 18. So the apothem equals 3 root 3. The perimeter equals 54. So 3 root 3 times 54 divided by 2 is going to give you 81 root 3 meters squared. Hopefully you're able to get there with it. All right, now pause it and try it with a square. All right, so the radius is 4. 90 cut in half is 45 and 45. So to go from the 90 to the 45, we divide by root 2. Make sure you rationalize it so you get 2 root 2 for each piece here, which would also make this 2 root 2. So whole side would be 4 root 2. So the apothem equals 2 root 2. The perimeter equals 4 times 4 is 16 root 2. So AP over 2. 2 times 16 is 32. Root 2 times root 2 is just 2. So 64 over 2 equals 32 inches squared. Now, of course, you could have just done 4 root 2 squared because it is a square to get the area as well. All right, what is the area of a square circumscribed about a circle with a radius of 16? Okay, so the square is circumscribed about, which means it goes around. So the circle's inside, and it has a radius of 16. So that means that is the apothem is 16. So each side, each piece here is 16 and 16, which gives you a side length of 32. So 16 times the perimeter is 128. Divided by 2 will give you the answer. 1,024 feet squared. Now, of course, you could have also just done 32 squared once you knew the side for the square. All right, one more question. This will involve not special right triangles. Find the area of the regular polygon to the nearest tenth. So here we have a pentagon. We know the apothem is 6. If we draw on the radius here, we can figure out what this angle is. So remember, 180 times n minus 2 over n. So 5 sides, so 180 times 3 over 5 will tell me what each side is. It tells me that each side is 108. Each angle is 108. Now, remember, it cuts it in half, so that makes that 54 and 54. And up here is 36. Okay, so it's very important that you remember that formula so you can figure out what angles go where sometimes. Now, we can use trig to figure out what each side is. So we can do tangent of 54 equals 6 over x. Cross multiply, so x tan 54 equals 6. And divide 6 by tangent of 54. So you get that each half of a side is 4.359. So you got to double that to get a whole side. So a whole side is 8.718. So AP over 2, 6 times the perimeter. So 8.718 times 5, because you got to multiply it by 5 sides to get that perimeter, divided by 2. So 6 times 43.59 divided by 2 gives you an area of 130.77. So make sure if it's not a regular triangle, square, or regular hexagon, that you're going to probably have to use trig to find your missing pieces. All right, please make sure you do your homework, and thanks for watching.